Friends, so in this video now we would be covering Newton's laws of motions. So forces we have done in the previous video. Now Newton's first law. In the first law we discuss about the inertia. Inertia is basically like if an object is here and if object is not moving and its object is at rest, so this object will remain at rest until we put some force over there. And if some object is here and this object is moving with some velocity v, so this object will remain in that state and it will go with v velocity until we apply some brakes. There is some frictional force or some another force that will stop the motion. So until and unless there is some force acted on the body, this body will not stop and it will go with the same speed, with the same velocity. And if it is at rest or velocity is zero, then also it will not gain any velocity until we put some force. This is the main definition, and definition for the first law I'll read it out for you. That is, body at rest remains at rest or at motion remains at motion until force is applied. So this is Newton's second law. Then Newton's this is first law, then Newton's second law. So Newton's second law is very important. It says the definition of force. So it says that force is the rate of change of momentum. So means rate means by time. So change of momentum is dp and rate is by dt. So dp by dt is equals to force. So force is equals to dmv by dt. Because p is momentum and momentum is equals to m into v. This is the common formula that we all know. From here we get two formulas. One is when the mass is constant. So when mass is constant, we get dv by dt. When the velocity is constant, we get dm by dt. So both are equal to force. So this formula becomes ma and this remains v dm by dt. So this formula is used when there is like some balloon questions, like there is a balloon, there is a air and we left it and this balloon has now moved in a random direction. So this air dm by dt, the change of the mass with time, or there would be some rocket questions. So there will be rocket and there will be fuel, so it will give a force. And this formula F equals to ma, this is very important formula. So this will be always used whenever the mass is constant, and basically mass is always constant. In our questions we say that this much force has been applied to this body which has mass of 5 kgs or 10 kg, 6 kg. So this mass is not changing. So when mass is not changing, we will use this formula. When mass changes, we use this formula, and both are the formulas of forces. Otherwise we say that no, these are not the only F equal to ma is the formula for force, but this formula is also very important. So apart from this, there is another concept in the forces, and that is called the impulse. So impulse is effect of force. It is not force. So force equals to dp by dt. So this is already we know dp by dt is force, but when the time is very less, like a ball strike to the wall and it moves away. So at that time we say that delta p is equal to f dt, and we call it denoted with j, and that becomes impulse, change in the momentum, and we will say it the final momentum minus initial momentum, like the whatever the momentum here minus this. So this is the final position, this is the initial position of the ball. So these types of questions would be there, like find the momentum, find the impulse. So we have to work accordingly that what we can do with the things that are given to us. So second thing in impulse is that there will be some graphs given to you, and this axis will be F and T, that is time. F and T. Okay, so F and T, the area under the curve will tell you delta P, and delta P is what? J vector, that is impulse. So to calculate impulse, you would be requiring to calculate the area under the curve of FT graph, that is the force and time graph. So this is now completed, the forces, and okay, we will complete that Newton's third law. So here in this video, Newton's third law is very simple, and it says that Newton's third law. Newton's third law, that every action has equal and opposite reaction. That's it. So Newton's third law says that action and equal reaction. So this will come into picture when we will have some linear momentum, conservation of linear momentum, and there will be one ball going over there that is getting strike to this. They will be striking and then it would be going away. So this we will discuss in the other videos. But up to this, we have covered all the forces part, Newton's first law, second law, third law. Okay, then see you in the next video. Hope this video has cleared your doubt and we would be working for your exam. Thank you.